Hello, my name is Teo Ting with the card metric number is DE180047. So today me and my group members are going to present about the project for our subject Computer Architecture and Organization. So the title of our project is the concept of computer architecture and organization. So I'm going to introduce my group members, which is Nur Rafika binti Razuhi, me as Teo Ting, and Nick Muhammad Asri bin Amri. Continue to present about the introduction of our project. So in this project, we are required to design an equation with the arithmetic operation such as add, sub, mul, divide, power, and loop. And then we need to derive the assembly language code to express the equation in Littleman computer system. So as we know that execution involved with 4 steps, which is fetch, decode, execute, and store. So basically, let me explain about what is the process involved with. So what is the function of fetch? Actually, fetching an instruction and loading it into instruction register, which we call it as IR, is usually referred to the instruction fetch phase. And then the IR is for the decode process, which where we read or decode the value in the register. And then next, execution process is occur where all the operations such as add, sub, mul, divide, execute in arithmetic logic unit take place. And then lastly, we'll store the data or we'll write back the data in the register occur, which is in the last phase. So Littleman computer is an instructional model of a computer. Generally, we use to teach students because it models a simple volume architecture computer. This is the general equation that designed by our group, which is P minus Q times R plus S divided by T plus V, and then power of 2. So the equation that we're going to present is this.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Nurul Rafika. I am from Group 11. So today I want to present about the assignment, which is the concept of computer architecture and organization. So then each group are required to derive the equation. Then this is our group equation. Then this is the value that I have declared. When we calculate, we can get the answer equal to 100. We also require to derive the assembly language code to express this equation by using the Littleman computer simulator. So, this is our assembly language code to express that equation. For the input, which is P, Q, R, S, T, and V, we have declared in this code, which is this coding. Okay. Then, we need to assemble it into the RAM. After we assemble it into RAM, then we can see that our value of the input are stored at the register 64 until register 69. Then you also can see that from the register 0 until register 99, it have 3 bits, which is the first bit are referred to the instruction register, second and third bit are referred to the address register. Then we need to run this code. After we run this code, we can see that the value 00 from the program counter are separate into 2, which is the first 0 value will go to the arithmetic unit and then to the process addition, which is its value will be plus with 1 and then stored back into the program counter to ready for the next instruction. Another value of 0 are referred to the register, meaning that this register 0 go to the RAM to fetch its value in this register 0, and then it bring the value to the CPU to store it for a while. Okay, if you can see that in this register 0, it have 564. 5 it is equal to the instruction, which is in this LMC. 5 it is referred to the load, meaning that it will load the register 64. Then the address register 64 will go to the RAM to fetch its value and then bring the value to store in the accumulator. Then it will do the next instruction, which is in the register 1, it will have the value 265, meaning that the 2 is referred to the instruction do subtraction. Okay, then the value of the 64 will be sub with the value of 65, and then the value of register 65 are bring into the accumulator, and then both of the value are going to the arithmetic unit to do the process of subtraction, and then it will go back to the accumulator. The next instruction, it will goes to the 390, which is it refer to store at the register 90. Then the value of the accumulator, which is 6, it will go to the register 90 to store it. Okay, so then for the next instruction is 902. It means to bring the value in the accumulator to go to the output window. Okay. Then for the 5 instruction, which is 000, it is refer to the HLT, meaning that it will break the execution, meaning that it will clear the instruction register and also the address register. The next instruction is 565, meaning that it will load the register 65. In this register 65, it contains the value of 2, which is the value of 2 will send to the accumulator, and then it will go to do the next instruction, which is 166, when it is refer to the add operation. So then it will add with the value in register 66. Okay, after that it will store in the register 91. Then this instruction, I code that to be stored in the register 80, which is in this register 80, I will use during the process of multiplication. So then, okay, it will do it. Then for the instruction 902, as usual, it will go in value of the accumulator will going out to the output windows. And then it will break the execution. At the instruction 11, actually it will start do the process of multiplication. If you can see that inside this code of multiplication, I have mentioned the code of BRP, meaning that BRP, if the accumulator have 0 value or positive value, it will loop again and again until the accumulator give negative value. When accumulator give negative value, it will stop the loop and then do the next instruction or do the next process. If you can see inside the RAM, the loop happen when the process reach register 17. It is because inside the register 17, it have the code 811, meaning that it will do the BRP loop to the register 11 again, because inside the accumulator does not have negative value. So for this equation, I have used 6 times with 5, and then the output will have 30. So meaning that to have value of 30, we need to have 5 times. That is why the loop happen for the 5 times. So I will fast the command. Okay, then you can see that the output, it will be 30 after we do the process of multiplication. At the register 23, it start do the process of division. Start from this code until this code, it is the coding for the division. Inside this coding, I have declared the BRZN. Okay, BRZ meaning that if inside the accumulator is not equal to 0, it will do this process until the BRA loop 2. BRA meaning that it will be branched to specific cell. When it running the code until the BRA loop 2, it will loop again to the initial process of division. After that, it will do the same thing, which is the BRZ, we see the accumulator. If inside the accumulator, the value is equal to 0 or not. If accumulator equal to 0, it will stop the loop and it will jump to this coding of N. It will do this process. Okay, then if accumulator still is not equal to 0, it will loop again and again. Then inside this equation, I also already mentioned that 30 will divide with 5, meaning that the output we will have equal to 6. So meaning that inside this coding of division, it will loop for the 6th time. So I will fast the movement of this. You can see that finally the answer will be equal to 6. It will do the loop. Okay, so then you can see that the answer will be equal to 6. Then there is a value of 10. Value of 10, actually it comes from the process of addition, which is at this coding. it will load the register 93, which is contain a value of 6, and then it will do the process addition, which is add with v. In this coding I have declared it as the value of 4. Then when the 6 plus with 4, it will get the answer is equal to 10. That is happen quickly because before the coding of addition, I did not declare the HLT, which is to break the execution. At the register 43, it start to do the process power of 2. So the code is start from this until this, and then in this coding it have the code of BRZ, meaning that if inside the accumulator is not equal to 0, it will do the loop process, and when inside the accumulator is equal to 0, it will stop the process of loop, and then it will jump into this code of AND, which is this 9, and then it will do all of this process, then it will end. So inside the code of power, it will loop 10 times because our value is 10 power of 2, which is 10 multiplied with 10. So final answer we will get 100. So I will fast the movement of the process. You can see that at the output window we will have the answer, it is equal to 100. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Asif bin Amrin. My matriculation card is CE180192. So right now I'm going to explain the equation with different input. Now as you can see on my right side, QRSTV. So basically I'm using 11, 3, 4, 1 and 5. So at my right side, as you can see, we are using a little mass computer with different input. As you can see at the bottom, it's 11, 3, 4, 1, 5 and 5. I'm going to reset and I'm gonna run. So basically the program counter 0 gets to 1, and then as you can see the 0 from the RAM is 563. Now it's going to go, the program counter will be 1, and then the instruction register will be 2, and then the address register will be 64, and the 64 will go back and then get the 003, and it will be minus. So 11 minus 3 is equivalent to 8. So I'm going to speed up. So the output will be 8. Go. So basically, the way it works is that the 5 goes to the instruction register, and the register will be 63, and then it will go to the table 63, and then it will take the value of 11 and put it in the accumulator. So after that, it will proceed to the program counter 1. Okay, so it's going to go to program counter 1, and the value is 264, where the instruction register will be 2, and the address register will be at 64. After that, it will take the value from 64, which is 3 just now, and then it will be subtracted to the value 11 in the accumulator, and the answer will be 8. So the output will be the first output will be 8. As you can see at this right side, it will tells you whether the data is load, subtraction, store, halt. So it depends on the right side. The movement is the same as the first one, the one that Rafika explained. And then the second one is where we prove whether the different input can be used on the same equation. So right now I'm going to fast forward to see if the final answer is correct or not. We're going to run again. Right, so 5. 4 plus 1 is 5. And we're going to run again. So this is the same instruction as the first one. Lastly, it will be like this. You get the output of 8, 5, 40, 8, 13, and the last one is 169. So after it gets 169, when you run, it doesn't run. It stops right there because that's the final answer for our equation. So when using the same equation, but with different input, it shows that it is usable for any sort of different inputs. So the answer for this is actually correct and can be calculated manually, and it will be 169. So the output shows the answer were 8, so you can see this, 8, 5, 40, 8, 13 and 169. It shows that the final output was correctly programmed and calculated. So after the program will finish and were to be presented to run again, it will not run, like I said before, and the operation will be halt because the final input is 169. So as you can see right now, I will get the, oh no, hold on. This one, I don't know what happened just now, but the final one I get this one. So 169. So we can prove that the answer is correct by using manual calculation and by using little mass computer with different input and the same equation. Okay, thank you very much.
So for the discussion, we know that von Neumann architecture consists of 5 components, which are input-output unit, control unit, logic unit, memory, and bus. So fetch phase occurs when the instruction register fetch the data from the RAM 0 until 99, and then we will decode it or read it by referring to its instruction, which is to see whether is there any arithmetic operation needed to execute in arithmetic unit or not. And then finally, the data will be stored in a certain location in RAM if there's been declared or randomly as well. So the basic mnemonic code that frequently being used are SDA, which is store data, LDA load data, R output data, HLT break execution. So if the system is involving with the decision making process, then we'll use the BRA, BRZ, and BRP code to make the decision. And then for the conclusion, concisely we are able to fully utilize what we learned in our syllabus throughout this project, which is all the chapter inside the subject, especially in chapter 4. So we can conclude that the simulation of using the Litterman's computer can be used as the central tool for computer architecture and assembly language, as well as is proven to be useful when using to calculate any mathematical problems. The use of the LMC and the simulation tool is a power tool that can be mastered and improved by using different type of coding depending on the equation. So that's all from our group. Thank you.